Hello? Hello, hello? Okay, testing. I'm going to talk about some questions about probability, algebra, and ratios. If you have more questions, just write me in the chat if you're here. If not, so write in the comment or something, and I will try to answer it as soon as possible. And we're going to see the first question. The first question is, with this list of different outcomes, when you throw two dice, you have the different outcomes, and the question that is asked, or the question that they ask me to solve, is how to know if I get a total of at least 10. So I need to find out the probability in this case of get at least 10. How could I get, in this case, the probability of get at least 10? So what I recommend for you in this case is what I recommend for you first is that add the outcomes to get the sample space in values that we can detect, and in this way we can find out the probability. So what I'm going to do is, with red, I'm going to put inside, I'm going to put the values that I got. If I add them, and this will be, I'm going to add them, so 1 plus 1 will be 2. Let me see if I can put that I have this one. 2 plus 1, 3, 4, 5, 6, 7. Now in this table I'm going to put 3, 4, 5, 6, 7, 8. Observe that here will be 4, 5, 6, 7, 8, 9. Here is going to be 5, 6, 7, 8, 9, and 10. Here is going to be 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. And the question that they sent me is to get a value that is at least 10. So at least 10 means 10 or less than 10. So it will be, if you focus, it will be all the outcomes, but these three. All the outcomes but these three are going to get at least 10. So you have 36 possible outcomes. I mean, if you're going to find out the probability, you just need to take a number of possible outcomes, or the sample space number, and the number of outcomes of my event A. And in this case, the event A is at least 10. So I'm gonna have all the outcomes but these three. So we can say that to get at least 10, this is at least 10, will be all the outcomes 36 minus these 3, 33, over all the outcomes 36. Now I'm just going to simplify the fraction, divided by 3, 11 over 12. So we have 11 out of 12 options to get a number at least less than 10. This is the first question that I'm going to answer about probability, a basic question when we study probability, that is about the use of theoretical probability. Now we're going to see something about experimental probability. I'm going to move this. Let me see. Okay. Yes, you can see it. You can see it. I'm going to answer this. Here we have two spinners, and they are a spoon, and when we spoon these spinners, we have spinner number 1 with these options, spinner number 2 with these options, and we want to draw the sample space diagram. Here you can see that there are two options, Philip and Danny. But if you observe the two spinners, you can see that in spinner number 1 we have 3 options to get 10. So you need to be careful when you do the sample space to include these 3 options of number 10, because if you don't include these 3 options, when you find out the theoretical probability, maybe you're gonna have problems. You're not gonna get the appropriate answer. So the first thing you need to think is, if you have a spinner and you're repeating the outcomes, so you need to put these outcomes in your sample space, in your table. When you use 2 spinners, we can use a table. When we use 3 or more, maybe it's better to use a tree diagram, or you can go to the multiplication principle to identify the number of outcomes. But in this case, we want to know what are the outcomes. So to know what are the outcomes, I'm just going to move to this. Observe that Philip's option is not very appropriate because he's just taking into account one option with 10. Danny is taking into account the 3 options. Now I'm going to add both numbers because I want to know what happens if we add both results of the spinners. So I got 15 here, 16, 17, 18, 19, again the same numbers, again the same numbers, and again the same numbers. Plus 10, so 25, 26, 27, 28, 29. Observe that the number of possible outcomes, the number of elements in the sample space, will be all the combinations. Even that you have only 10 and 20 here, you have to take into account all the combinations. So the number of elements of the sample space will be 5 in this case times 4, so you have 20 outcomes in your sample space. Now the question that they send me, that they want to answer, is this one that says that Geronimo spins both spinners 20 times at the same time. He adds the results and he records the numbers. And we want to know what happened to the theoretical probability and the experimental probability. So you can see here that it's sent 20 times, and you want to know what happened to the probability of getting 18. So look at that, the probability of getting 18, the experimental probability of getting 18, it's going to be 2 out of 20. Experimental probability of getting 18 is 2 out of 20. I mean 1/10. And if I go to the table of the theoretical probability, this doesn't sound like a 2. You can see that the probability of getting 18 we have here 20 outcomes, so the theoretical probability of getting 18 is 3 out of 20. So look at that, the experimental probability of getting 18 is not equal to the theoretical probability, but even that it's not equal, it's pretty close. And this is what we expect. When you perform an experiment, and it's a random experiment, and you did your sample space, and you know what is the theoretical probability, it is expected that when you repeat the experiment many times, the experimental probability becomes the theoretical probability. And this is something that you can see here. As both fractions, 2 out of 20 and 3 out of 20, are pretty close to each other, we can say that the experimental probability corresponds to the theoretical probability. Now, it's asking what happens if he repeats the experiment 30 times more, and how should be the probability, or how is the change of getting 17. So I'm going to see what happened here with the experimental probability when I got 17. So we can 1, 2, 3, 4, and 5. So Geronimo got 5 times 17. So the experimental probability of getting 17 it's going to be 5 out of 20, or if you want to simplify it, it will be 1/4. However, the theoretical probability of getting 17, that it's here, is 3 out of 20. So the experimental is 1/4 or 5 out of 20, but the theoretical is going to be 3 out of 20. So what I expect, what is expected if I continue throwing this 30 times more? I'm going to put this as a percent. This is 25%. The experimental probability is 25%. And in this case, I just need to multiply times 5. So if you multiply times 5, you're gonna get 15 out of 100. So 15%. So what is expected? What's going to happen in the next 30 times more? What is expected to the experimental probability of getting 17 is to lower to the 15%. Maybe it's not going to lower up to 15%. Maybe it's going to lower to 20%. Or maybe it's going to get down to 18%. We have no idea. However, it is expected that the experimental probability change in favor of the theoretical probability. So if it was 25% and the theoretical is 15%, what we expect is to have a decrease of the experimental probability to get 15. In terms of throwing the dice, or the spin, sorry, in terms of spinning our spinners, it means that I expect that have less 17 outcomes during the next 30 times experiment. Okay, obviously we don't know what's gonna happen. This is something that we expect, but we have no idea. Okay, that's the second question. Here it says, can I solve the equation 2x plus 2y equals p? Okay, let's see how to do it. I'm going to change to abort, and I'm going to do 2x plus 2y equals p. I can imagine that we're going to make the subject of the equation. So 2x plus 2y equals p. And okay, I'm going to put that, make x the subject of the equation. Make x the subject of the equation is just solving the equation for x. So what we're going to do is just solve this equation for x. This is what we're going to do. And to solve an equation for x, my recommendation is that you use inverse PIMA. So if you remember order of operations, you know that PIMA stands for parentheses, exponents, multiplication and division, and addition and subtraction. So what you need to do is to apply inverse PIMA. So you're going to start with addition and subtraction, then go to multiplication, then go to exponents, and finally to parentheses. This is the idea of doing inverse PIMA. This is my recommendation. But I can suggest that before applying inverse PIMA, so like before here, I will tell you to simplify the expressions. Simplify both sides if possible. This is my suggestion. I mean, you can do it without simplify both sides if possible, but this is just a recommendation. In this case, The terms on the left side are not like terms, so I cannot simplify more. And the term on the right side, it's just alone, so I cannot simplify it more. So I'm going to apply inverse PIMA. And inverse PIMA stands DA for addition and subtraction. So I'm going to find out, I'm going to use this. I'm going to put my X in red. That is the subject. I want to solve it. And I'm going to focus on this part to apply inverse PIMA. What is the term that is adding my term that has my subject? In this case, the term is 2y, so that is adding. So what I'm going to do is to subtract both sides by 2y. Now, what is tricky here? What is tricky in this case? What is tricky is that these aren't like terms. So maybe you will try to add them, but you cannot add them because they are not like terms. You have to put the expression. I mean, p minus 2y. After you have the first part, now I finish my part of addition or subtraction. Now I'm going to the next. Let me put again my subject in red. And now what I'm going to identify is multiplication. What is the term that is multiplying my subject? In this case, the term that is multiplying my subject is 2. So I'm going to divide all my term by 2. But if I divide on one side, you should divide on the other side. So I got 2 divided by 2 is 1. So I'm going to get x, I'm putting my subject in red, equals p minus 2y over 2. And now I have my subject. Observe that what I'm doing is just, in terms of making the subject, I'm just organizing the information to apply inverse PIMA. But first, remember, first simplify the expression. This is very important. If you simplify the expression, you wouldn't have any problem with this. Now I'm going to a next question that they sent me about probability. Probability, I'm going to change the board to work on another question about probability. Okay, so you can see here, it says use the bar graph to find the experimental probability of the event. And the specific question is, okay, all the possibilities here. For example, what is spinning a 6? Spinning an even number, not spinning a 1, spinning a number less than 3. And you can see here that I have, let me put a color, maybe red, the number spoon on this side and the times that it was a spoon on this side. So this is kind of a frequency table. So you can, instead of writing time spoon, you can write frequency. And you can put number spoon. I would prefer to do a histogram, but okay, I'm not judging the graph. Now you can observe that 1 is, the frequency of 1 is 8, the frequency of 2 is 6, of 3, 9, 11, 9, and 7, okay? So you need to get first what is the total number of outcomes, because if you're going to find out experimental probability, you need to use them over, the experimental probability will be the number of total outcomes, and if this is an event A, so the number of times I got A. So what I'm going to do here is to first count how many outcomes I got at all. So I got 8 and 6, 14, 14 and 11, 24, 25. Sorry, not 11. 14 and 9. 14 and 9, 23. 23 and 11, it's 34. 34 and 9, 43. 43 and 7 is 50. So we have 50 outcomes. So spinning a 6. So if I want to know spinning 6, I just need how many times I spoon 6 over 50. And 6 was spooned 7 times. 7 over 50. Let's say you want it, in this case it's easy for us to get it as a percent because I just need to multiply times 2. If I multiply times 2, I'm gonna get 14 over 100. That is just 14%. So this is how you can get the experimental probability. Now spinning an even number. So I'm going to do A and B and let you C and D for you. Okay? Spinning an even number. If you spoon an even number, so even, so P of E equals, sorry, I'm going to put N even. Actually, in technology, if you follow something about programs and how to program, there's a way to put this in upper terms that it will be divisible by 2. Okay, but I actually forgot how to do it. I know that there's a way. Now even, so just take the even numbers, 2, 4 and 6. 2 is 6 times, so 6 times, plus 4 is 11 times, so plus 11, plus 6 is 7 times, so 7 over the total, 50. So 11 and 7, 18, 18 and 6, 24. 24 over 50. You want it as a percent? So this is the cool part, because you can multiply it times 2 to get 48%. And this is how you find the probability. Not spinning a 1, so it will be all the numbers, all the possible numbers, but 1. All the possible numbers, but 1. Or you can get the experimental probability of getting 1 and take 100% minus this probability, that it will be the complement. Spinning a number less than 3, so numbers less than 3. There's a problem with this one, that when people ask less than 3, there's a problem, and is that some people include the 3, but it says less than 3. So remember that 3 is equal to 3, not less than 3. This was the other question. And finally, they sent me this one about cards, that says your friends want to perform a major trick and ask you to draw 2 cards from a standard deck of 52. So you have a deck, you take 2 cards. The first card you draw must be placed face down and the second place face up on the table. How many ways are there of drawing the 2 cards? So, okay, the way I prefer to do it is by multiplication principle. So I'm going to imagine 2 boxes. Okay, it doesn't identify my box. 2 boxes. Let's see if now I identify the box. No. So I'm going to use 2 boxes. Done. This box will represent the cards that are face down. And here, the cards that are face up. Okay, and it says that the first card you draw must be placed face down, so it will be this one, and the second place face up on the table. So what I'm going to do is to identify how many options I have for each one. If you have a deck of 52 cards and you're going to take 1 card, so the card you got is one of these 52 cards, so you're going to have 52 options. And then you put it face down. So how many cards you have in the deck? 52. So you have 52 cards. You take face down So now you have 51 cards in the deck. From these 51 cards, you're going to take one to put it face down. So you have 51 options. And the question is, how many ways are there to draw in the 2 cards? So you just need to multiply numbers up, down. Will be just the multiplication, 52, sorry. Oops, something happened. (52) times 51. So I just need to multiply these 2 numbers. Oh, I don't have calculator. Oh, too bad. So 52 times 51 is 50 plus 1. 52 times 50, 5 times 2, 10. 5 times 5, 25, and 1, 26. 50 plus 52. Distributive property. And that will be 2,652 cards. So you have 206,052 options for you to have this answer. Okay, so this is about probability, how to select using the multiplication principle the number of outcomes. We also talk about how to get the sample space to calculate theoretical probability. We also observed how to use the number of outcomes in an experiment to get the experimental probability, and we also get how to identify changes in the experimental probability due to the theoretical probability. This is what we have seen here. Let me see if there are more questions about it. Yes. Sorry. Yes, there's one more question that they sent me here, so I'm going to find it. It should be in some place here. It should be in some place here. Let me see. It should be in some place here. I think it's this one. I think it's this one. Let me check. Give me a second. No, it's not this one. It's shirts. It says here. It says label the probabilities in the tree diagram below and determine what is the probability of wearing a red shirt and black jeans. Look at the shirts and jeans. So we gotta find out the probability of getting red shirt and black jeans. Okay, finding the probability in this case with the tree diagram. The tree diagram is another way to know the number of outcomes, to know another way of the possible changes that you have. And in this case, I'm just going to find out the probability of getting red shirt and black jeans. So in this case, this is one option, second option, 3, 4, 5, and 6. So I have 6 options, and from these 6 options, I have only one option that is this. Like this path, like red shirt, then black jeans. So it will be 1 out of 6 because you have one option out of 6. So the probability of getting red shirt and black jeans is going to be 1 over 6. Okay, this is how you can calculate this probability. Usually in tree diagrams, you can put what are the probabilities according to the result. Observe that this tree is divided in 3 parts. So it means that this is a probability of 1/3, 1/3, and 1/3. Now observe that if I just focus on this place, the probability of getting these two will be 1/2 and 1/2. Okay, let's say that I know that it's a plaid shirt, so I'm going to divide it in two parts, 1/2 and 1/2. And if somebody asks me what is the probability of getting red shirt and black denis or black jeans, I just need to multiply these two, 1/3 times 1/2, and I'm gonna get 1/6. Okay, this is a very good strategy using the tree diagram of how to calculate the probability. I'm not very deep into. I prefer to count the number of options and take the event and divide by the number of options, and that's it. Okay, I don't like to complicate myself with this. Okay, so we discussed about probability, we discussed about something of algebra, tree diagrams, we discussed about experimental probability and theoretical probability, and I hope that this video really helped you to understand the uses of probability and how to identify when we use experimental probability, when we use theoretical probability, and how to answer this type of questions. Okay, see you in the next video. Enjoy this alive, and bye bye. See you.